Hello, my name is Chris Malater. Again, I work with TDS. This is my second time doing this panel, and I hope that you all enjoy this panel because many of the operators from last panel definitely expressed interest that we had such few spaces that there's lots of opportunities for more operators to keep doing more panels. So I hope it's as interesting for you as it is for all of us, and that we can keep going with this as a regular program item going forward. Hello. Just to give you an overview, when I asked for people to be on the panel, I didn't really want a lot of who you are and where you are and what your pricing might be. I really wanted the what is new and what challenges do you see and what are you doing going forward. And that went really, really well last time, and so I kept that same principle with the folks that you see up here. So then we'll have speakers. I reduced the number of speakers on this panel after feedback from last panel that there wasn't enough time for questions for the speakers. So if you will hold your questions till the end, we will get to them at the end. So I have Mike Hughes from the Lynx, Dave Meyer from Oregon IX, Tom Beckley from MCI May, Troy Davis from the Six, and Celeste Anderson from Pacific Wave. There's quite the variety of different types of exchanges, be it commercial, membership-based, or educational research. So with that, I will introduce Mike Hughes.
Okay, thanks, Chris. I just want to go and just publicly, big up Chris and the efforts that he's put in to run this. He's put in a lot of time for this, and it's great that somebody can actually do that. So, round of applause for Chris for putting the effort in, and I think more than anything, getting us together because it's like herding cats. I'm going to go and talk about our upgrading to 10 gig and beyond, the real-world experiences that we've had over the last few years, and where we're going with that. That kind of fit in nicely with my comment there that actually, 40 gigs to me is anyway not really a lot of use. Quick slide about where we are right now. 173 members connected, another 10 in the post on the way, 27 countries in total, from pretty much every continent except Antarctica and Australasia. Actually, no, we've got Reach, so we've got Australasia as well. So we've got everywhere except Antarctica. Present at 6 carrier hotels in London. This differs from the US area situation where the exchange in Europe is actually usually not owned by the carrier hotel. It's a separate switch operator. So we don't own the facilities. Those are dealt with by companies whose primary purpose is power and cooling and security and those kind of things. It's a dual platform, multiple 10 gig ring design, 2 separate public peering LANs available across all sites. We use Foundry and Extreme switches. On the switch traffic, we've got about 56, it's actually 57 gig a second today. And we've got managed private interconnects, roughly about 25 gigabits per second across managed private interconnects that we run for people. So 10 gig, we've been running it for quite a while now. 2001, Foundry went and made 10 gig modules for their Ironcore Big Iron 8000 platform that have been around for quite a while. We've run that in our backbone, and it worked. We just plugged it in and it came up, and it wasn't really anything to be scared of. We've recently completed an overhaul of this. We deployed Foundry's MGA. We did this because we obviously needed to offer 10 gig ports towards the members, and also we could quite happily fill up a Foundry 15000 with gig-E ports from our members. So we needed more ports in a single box because the busiest site is, almost 80 gig ports in that site and growing. It wasn't completely problem-free. We had some issues with the line cards crashing, but we've got around most of those issues now. They've been patched, and we're now connecting up our first 10 gig participants. And the other thing that we're seeing as well as 10 gig is obviously a growth in link-out connections, but we found bugs in member routers. If you've got a Cisco with a Tetra or Trident line card, you'll get these beef food floods, and these seem to be a lot more prevalent in a trunk connection. And there's also some high CPU load conditions. But of course, we're going to do everything twice because we have 2 VLANs, and we really love pain and maintenance work and sorrow. So we're going to go through this again. So we're going to go through this again. It does mean we get to do things twice, and we can go and use the experience from the first time round as a cushion for the second time round, and use that experience to help us try and do things a little bit better this time. We're going to upgrade the Extreme platform to be of an equivalent specification because both networks need to be roughly equal. They're load sharing, redundant networks. So that's why we have to do that. And I'm currently in the selection process, so I'm slightly limited what I can say. I obviously don't really want to upset the guys that we're dealing with at the moment that we're negotiating with. But if anybody does want to talk to me privately about that, feel free. Quick selection data point. I went and got our packet data, and the majority of our packets, about 60%, are all small, less than 128 bytes. Then about another 30% is big stuff, and the remaining 10-15% is the stuff in the middle. And that means that we've actually got to be in a position where we can have consistent performance across the box from small to large packet sizes. So that actually is a major selection criteria when we're looking at kit. We need to have this consistent, predictable performance, particularly with stuff like VoIP and interactive stuff like video conferencing. And hey, we've always got guys doing gaming as well. What shouldn't happen when you're upgrading things is sleeping on the packaging from your equipment. This is one of my engineers getting ready to bed down for the evening. What's changed this evening? This time, actually. There's no big bang. So when we did the Foundry stuff, we went out and we ordered a load of kit in one go. What we're going to do this time is we're going to trickle the hardware in slowly. We're going to take a box, do a bunch of acceptance testing and acceptance criteria, get it into the network. And it really outweighs the disadvantages of the homogeneous network because we can just go at a steady pace. The other thing, test as much as possible, and then when you think you've tested it all you can, test it again. I don't think you can be too thorough within reason. Part of the reason that we had issues with the MG8 was that we hadn't been able to do enough testing, in our opinion now, in hindsight's a great thing, of the 40 port 1 gig line card. And also we have agreed acceptance criteria with the vendor, especially for that first system, an acceptance criteria for when we actually go and give them some money and order some more stuff off them. And then obviously if it doesn't meet the criteria, we get them to come in and take it away. So that's basically the 10 gig thing. Where are we going really? Well, it's N by 10 gig now. We're already doing trunking. As I said earlier, 40 gig isn't much interest to us because this is a metro network in Docklands. Dark fiber is relatively cheap. I'm paying, what can I tell you that's not under NDA? I'm paying less than £100,000 a year for a 15-year IRU. Not a year, I mean £100,000 for a 15-year IRU. So that's like, next to nothing. So, the 40 gig stuff really isn't that interesting. What we're doing at the moment, we're currently working on some other projects. We're looking at multicast distribution. There's some more interest in that area. Using the PIM snooping on the systems to control multicast behavior and stop stuff flooding. Looking at doing shared DDoS mitigation, so by having a communal scrubbing facility, and that's using a British-built cleaner developed by a British inventor. Also trying to solve the VLAN issues, provisioning, tag space clashing, associated renumbering and all that kind of pain, trying to work out how to make that kind of thing scale. So that's going to be something that's discussed at the Links meeting in London next week. One of the approaches I took was to go and ask other people what they were doing about doing VLANs and tag space clashing. A lot of it was just manual. Just go and have a big list and try and work out a VLAN that works for everybody. I went and spoke to the guys over at May Services. They have 6 full-time programmers writing tools so they don't have tag and VCI clashes and that kind of thing. And the other thing is collecting S-flow data for traffic management purposes. Anybody who's an Equinix customer is familiar with that kind of thing already, and we're currently working in that area right now as we've got that available in our Foundry switches and also coming along in the Extreme platform. And from me, that's it. Anybody, do you want to take questions now? Or?
Let's do questions after.
Questions after, okay. Right, thanks folks.
You want to plug in?
Yeah, I think I can do it right here. There's another.
No, I'm using the other one.
Oh, okay, because you don't use this.
Yeah, you can steal it.
So I'll take a second.
Dave Meyer from Oregon.
Okay, this is going to be a little bit different. I got it. Many of you have maybe been to Oregon before, or to Eugene before, which is where the Oregon Internet Exchange is. So I'm just going to talk a little bit about where we're at. That sort of worked. Okay, so agenda looks like brief history, current status, futures, and if anybody would really want this talk, it's right there. So here's the first problem is, when I talk to people about this is, many people here maybe know where Oregon is, but it's kind of the rectangle. Did that work? There's kind of a state between, we're in Washington right now. There's a big state southwest called California. There's a kind of a rectangular one in the middle. That's where Oregon is, in case you're wondering. But if you take a slightly closer look, you'll see that the Oregon Internet Exchange is in Eugene, which is kind of right in the middle of the state on the west side of the Cascades. And it's kind of a smallish kind of town, about 120K people, but it's not a large metro area, which presents all kinds of problems for trying to build an exchange there. So here's the brief history of how we got here from there. Basically, I was over across the street from the U of O in the Northwest Christian College, and I noticed Randy's RainNet pop was like under somebody's desk. And there's a bunch of modems and wires and stuff, and I said, hey, Randy, why don't you bring this over to the U of O and we can peer and maybe get you some better space. And that's how this all started, as sort of a very cooperative regional effort. And so it was RainNet, U of O, and what at the time was our experimental State of Oregon network, which is now morphed into the State of Oregon production network. And well, we had a 100 megabit switch, or a 10 megabit switch, because we weren't exchanging a lot of traffic. And we had Quest Fiber, but it wasn't fiber that was available for anybody to use. It was just what they were bringing their services in on. So we had a very small start. Oh yeah, and we had some idea of colo space. This is what I kind of hooked Randy on. I said, hey, we got all this great space over at the U of O. And it turned out that we just hijacked some space in a closet across the street from the U of O, and that's how it all started. Well, nowadays we have about 30 peers, and they're mostly regional. The downturn had substantial impact on the number of peers we have and the amount of traffic that we're able to that we have. Our switching environment's a lot less commercial than what we just heard. It's just dual HP 2800s. We have 100,000 people are connecting on all of those, both fiber and copper. There's a common IPv4, IPv6, and multicast fabric there, so you can do what you want on it. And nowadays we have several regional, local, and long-haul fiber providers, so it makes things a little bit easier for people to get in. And we also have sort of a telco-grade conditioned environment, which is the U of O switch room, which is more or less telco-grade. So that's kind of the situation there nowadays. The kind of services we try to provide, well, we do cross-connects for people when they want them, and we do remote hands. And we also do this kind of consulting because a lot of the people who want to connect here are small regional school districts, things like that. And so they frequently need help with routing, switching, DNS issues, DOS prevention, send mail configurations, all of these things we try to help people with. Again, under the regional cooperative kind of moniker that we have here. And so let me just say a little bit about where we're going. Well, we're building additional fiber facilities, both metro, regional, and in the state, which is kind of a good thing for this. People can get there from here. We're thinking we want to upgrade to 10G, but the reality is we don't have enough traffic to justify it. And then in the services thing, we have some experimental VoIP pairing things we're doing with local people, and some eCache kind of experimental stuff that people are asked us to do. We're looking at doing layer 1 or layer 2 extensions, mostly up to the Portland metro area, because again, this has to do with where population density is and where people need to exchange traffic. The South Valley, which is where Eugene is, doesn't really have enough population to have a lot of traffic being exchanged there. And okay, so of course we'd like to have more traffic, and I think that's about all I have. Okay.
Tom from May.
Hi, I'm going to talk about May services as we're evolving. So the May services, if we look at MCI, which is the owner of that, it's really a network service provider primarily, not a co-location or a carrier neutral facility. And we've evolved the product towards from a peering perspective towards remote peering. So, peering requires, as we all know, delivering traffic from your network to your peer network. So you either have to, build out a national or global network. You have to lease facilities from a service provider to get to the exchange point, or you can reach it through some arrangement through another service provider network. And so remote peering, allows us to meet the needs of a certain segment of the community, whether that have regional networks and don't have the economic or need to, or the business case to build out nationally or globally, but still want to be able to exchange traffic or to peers that are in other places besides where the network exists. So this can potentially reduce their costs, gives them control over routing over the path, that they have more opportunity to have different paths, and via fewer AS hops, there is some potential to provide a better customer experience. So these are sort of the arguments for remote peering, some of which were covered in depth at the remote peering debate in Kyoto a couple months ago. So May has sort of launched a new service called May XT, Extended Services, and it's really a suite of services provided from a single port or a single entry point to ISPs in general, in the broader definition of ISP. So you can, there's either remote or local peering available, L2 VPN, full transit or partial transit. So from a single port or a sub-interface on the port, these services can all be made available. So remote peering is the first example. And if we take the Moon V6 prior to, because earlier this morning, UNH was connected via May in New York. The France Telecom was hosted on AS6066, which is in San Jose, connected to May West. Some of the other participants were connected to May East in Ashburn. They were able to peer, to do native V6 peering over the infrastructure. And so that's an example of remote peering for that set of tests. A customer can extend their network without having to build out facilities. They could place a router attach it to a May exchange point on the East Coast if they're primarily based on the West Coast, and be able to then exist there without having to, at a lower cost. It's basically usage based. And so there's some trade-off or some crossover to where that may be more economic than building out. And then transit is available. So from this same port, you could either make an arrangement for a full view or partial view. And the partial view is AS701, obviously. AXT is a connection-oriented service, and so it's not a bridging domain, as is typical of exchange points. It's a connection-oriented service, so and the customers can attach either GigE, packet over sounded frame relay, or ATM, though that's a diminishing quantity. And in a sense, and all services are delivered over a sub-interface, whether it's 802.1q tag or a DLCI or VPI VCI. The platform does perform interworking between the different layer 2 attachments. So ATM can exchange, VPI VCI is mapped to a DLCI or to a 802.1q tag, etc. For both V4 and V6, the only caveat is the V6 interworking won't be available till July, roughly. We have some waiting on a vendor load to be put out to support that bit. The services are usage-based, and so for the remote peering or the L2 VPN, it's 95th percentile based on traffic pushed to the network. So a content provider might have a connection to an eyeball-oriented entity. They would exchange traffic, but the bill would reflect what they push. So there'd be the content guys always seem to have to deal with a large amount of traffic. The other end might be less, depending on the application. Transit is your pretty standard 95th percentile greater transfer receive. Transit today is V4. We expect that V6 transit available 3Q, and again for the peering and the L2 VPN connections, the customer self-provision those, being PeerMaker, and a lot of people are familiar with that service. The current locations are in Vienna, the Infomart in Dallas, Marketplace Star San Jose, NAP of Americas Miami, Avenue of Americas in New York, Printer Square in Chicago, and then one in Wilshire. So the focus is making this accessible to carrier-neutral facilities or close to carrier-neutral facilities to minimize loop costs, et cetera. For attachment, we're looking at bringing up 111 8th Avenue in New York in the next month or two and connecting it in. And so then I sort of talked about the U.S. View, and then we're working on globally building this out right now. Most of the focus is on the North Asia, Tokyo, Seoul, Hong Kong, and the other. And so this would be, and there's two views of this, or two models of how we're going to look at carrying this forward. One is via having a switch in those locations and the customer attaching to the switch, and the other view is to, we've talked to some of the other exchange point operators, and in some cases we may attach a GIGI or some kind of handoff to another exchange point operator, and they would be able to pass us a tag. We'd pass them a tag, and one of their customers could, say in Europe someplace, be able to exchange traffic with someone in Asia over a VLAN, and so the service endpoint would be a sub interface or a tag as opposed to a port interface. And that's basically what we're doing, where we're going. I think that's.
Thank you, Tom. Next, Troy from the 6th.
So this is the abbreviated formatted version. Good, it shows up. Excellent. So welcome to Seattle. This is our exchange point. I'm with the 6. Needless to say, it's next door at the Westin building. We're in the hotel, the Square building, which you probably had a tour if you toured the Switch and Data facility. We're on the 19th floor, right next to the Meet Me room. So if I had an official title, it would probably be Exchange Point Janitor. And you'll see here in a second, we're literally in a broom closet, which has worked out pretty well for us. It's secure, it's got a lock and key, it's convenient for cross-connect. We're able to do single mode, multi-mode, copper of course, pretty much any medium you want. A little history, the 6 came about back in '98 when IXA and WolfNet, I don't think either of which are still around, but they wanted to connect because they got tired of going through San Jose, going through the East Coast, just to get between 2 floors. The usual reason for starting a regional exchange point. So got a couple folks together, and I think the original exchange was actually just the 2 of them. The hardware materialized, and that's been true ever since. We've been real fortunate in that every time we've needed new hardware, donations have just kind of sprung up. And that was true the first time around, still true today. In 2001, we formally incorporated, and so we're a 501c3 now, legitimate nonprofit. No, we're not? Oh, do tell. Just a state nonprofit, okay. We're not legitimate then. But we'll still take your money if you want to donate. So what we've got is effectively each peer has 1 share. Correct me if I'm wrong here, Chris. Okay, and every year we vote for three peers to be on the board of directors, serve a 1-year term, and that's been real successful as far as governance for us. There's enough folks who are interested in running the exchange and interested in seeing the operations. Now, granted, it's been more or less the same board for the past 3 years. In fact, exactly the same board for the past 3 years, but that's worked out real well. So let's see. Since we don't actually buy any hardware and we don't pay anybody, we're able to have pretty much free peering, and that's true for all of our ports. So where if you're used to paying at least a cross-connect fee or a port fee or something somewhere, we charge nothing to anyone. We've got about 60 peers, and this doesn't show up, well, okay, it shows up better there than it does here. You can kind of see, we're hoping that Metcalfe's law is kind of scaling in this direction. We got a little bit of the network effect happening between 02 and 03, you can kind of see, but really in that last year, we're starting to get a hockey stick. It's been kind of cool to see, just from a personal perspective, what's required to run a small exchange point. And if you've got it in your head that it's not too hard to run a switch and cluster a few switches together and connect some folks to a switch. Well, you're absolutely right. There's nothing rocket science here as far as running a regional exchange point. It's about as easy as you'd expect. I think because the 6 is free, it's been a neat case study for what happens when people can peer who otherwise wouldn't be able to. In that regard, a bunch of our peers, especially if you look like 2000, 2001, a bunch of our peers were doing literally a megabit, 2 megabits to the exchange, so nothing at all. Those folks, you would have never gotten them to an exchange point before, and they would have never, in some cases, they weren't even multi-homing aside from the 6 and some primary transit provider. But it was because of those folks that we were able to go and get larger peers to come in. So if you look back like 1999, 2000, we had 15, 20 peers and maybe 300 megabits worth of traffic. Well, a bunch of those same peers have been acquired, they've increased their networks, what have you. So just organically, we've gone from a bunch of folks doing 2 megabits apiece to now a bunch of folks doing 15, 20, 30, 40, 50 megabits to the exchange. And so in our regard, or in our case, small is temporary. We try to limit our scope. As I mentioned, it's a 3-person board of directors, and I've kind of got the operations hat on. So we can't do a whole heck of a lot, and we have no money, so that doesn't help either. What we do, though, is we operate a really reliable public peering point. We don't do any VNIs or PNIs. We don't do any private VLANs. We don't have a route server. We do very little except that. And for a lot of folks, we're pretty much transparent with what they're used to. A lot of our peers, like we've got Microsoft, we've got AboveNet, we've got Netiphus. You can check the website and see all sorts of stuff. But a lot of our national peers call us, and their operations group don't even recognize that we're a nonprofit or that there's anything distinct about us versus any of their other vendors. And for a nonprofit organization, at least to me and one staffed pretty thinly, it's impressive. And that's all from donations. Folks have donated their time, donated their infrastructure to handle the calls, donated their network operations expertise. So I mentioned we've seen some real strong growth in the past year. Some of that's been organic, so we've seen a bunch more traffic from peer-to-peer folks, or peer-to-peer traffic from existing folks, and that's driven some recent interconnections. We've gotten Shaw, we've gotten Group Telecom, some of the other cable providers out of Canada, and folks who are local, Millennium Digital. The other thing that's been kind of neat is we finally hit critical mass, for my definition, with NNTP. We've got a bunch of Usenet providers, and they're at least to the point where if you go and you're offering Usenet services, or you've got a ton of eyeballs, you've got some reason to carry Usenet, we're at least able to inspire you to connect if you're in Seattle. That wasn't always true. If you look at our traffic, probably a good third of it right now is NNTP. We're quietly reliable, and by that I mean that we don't actually do much. We sit there, we've got our 5 switches, and it runs. What we do is we'll limit each port to 2 MAC addresses. We're an all-Cisco shop right now, or all-Cisco exchange point, I guess. 2 4912Gs, 2 3508s, and a 4003, so nothing exotic happening here. We do port security, so if you plug in and you plug in a switch and you don't have spanning tree disabled, and you try to send a BPDU, we'll shut your port down. If you plug in and you go above the number of allocated MAC addresses, we'll shut the port down. That served us pretty darn well and prevented what would have been otherwise cascading failures. So no individual peer has been able to cause any problems in that regard. And actually, we've seen that the switch fabric has been reliable. And Chris, you've seen this more than I have. I think we're coming up on 5 years now with no switching outage or other issue. What we did have is we lost power for about an hour. It's on generator now. And last but not least, the The gentleman who mentioned upgrading to 10 gig E, one of these fine folks, yeah. Well, we just went to 2 gig E, so we're on the right path.
Hey, we
Yeah.
started somewhere.
It's a good start, and we achieved 60/40 load balancing, so kind of a miracle. We did ether channel between the two 4912s. Otherwise, not much in the way of interconnect engineering. We got lucky though. The week after we went and did the ether channel trunking, which was capacity driven. There's maybe a gig on that circuit now. The week after we went and did that, we got offered 2 black diamonds for free. So it sounds like we'll be doing a forklift upgrade in the next month or 2. If anybody's driving from San Francisco to Seattle, let me know. We've got some extreme hardware we'd love to put in the back of your truck. New locations. We've actually heard interest, and this kind of touches on the bottom topic. We've heard interest now from folks in Vancouver, BC, and as well from 2 small cities in Washington for extending the switch fabric to data centers in their space. And the market is actually, it would be a peer coming in, connecting to the exchange point, and selling transport effectively, selling an extension to the switch. So it looks pretty likely that the Vancouver extension will happen. So if you're in Vancouver and want to reach the 6, it's going to get even easier. Then also, if we could get access to fiber cable, we would try to get to Fisher Plaza in Seattle. So I'd say 50-50 whether that happens this year. One note. Every time I bring up the 6, somebody asks, what do I do to start a regional exchange point? And I think Seattle had some pretty unique characteristics. We're 900 miles from San Jose. We're near water. We're near Canada. So we had this built-in set of peers ready to come in and connect. But what I wouldn't want to see happening is every little city starting an exchange point just for the sake of having one. So what I tell those folks is it's a means, not an end. And in the case of Seattle, we needed it at the time, and I think we still do. But if you're in a city that doesn't need additional interconnect capacity, be happy. And I'll be giving tours if anybody's interested, or questions, what have you. Thank you.
Celeste from Pacific Wave.
Hi. I'm here representing Pacific Wave at this moment. And Pacific Wave is a collaborative project between the Pacific Northwest Gigapop here in Seattle and Scenic, which is the educational network in California. And I'm from USC, so we're collaborating, as is the University of Washington as well. So why do I put up a glyph map? Well, you can't see it real well, but there's a little circle on the west coast, and this part of the Global Lambda integrated facility is Pacific Wave. We're providing services to the glyph community. And the reason I put this map up is to show all the different educational networks that are coming in and interconnecting. And that is part of, we're just kind of a small piece of this larger international effort. So we have 3 locations in Los Angeles connected by 10 gigabit. That is connected through Sunnyvale, and in July we'll have 2 locations in Sunnyvale, and that has a National Lambda Rail Lambda that goes from Sunnyvale into Seattle, and it's next door in the Westin. I don't expect anyone to read all of these, but this is to show a little bit about how we're deploying our VLAN topology. It's complex, and it got even more complex when we decided that the jumbo VLANs should be segregated from the standard VLANs, so everybody who's capable of doing, and when we say jumbo, it's 9,000 MTU, so anyone who's on that has to agree that they're going to peer at 9,000. The switches are set to the highest value, so they can actually do higher than 9,000. But at any rate, now people are actually going to be capable of doing the standard 1500 MTU, but also the jumbo, because many of the research people are actually doing things that require jumbo frames. So, features, activities, plans as we were asked to do. We have separate VLANs for standard and jumbo, as I mentioned. Multicast is in the same unicast VLAN via PIM snooping, so we don't do a separate connection for multicast. And IPv6 is in the same VLAN as our IPv4 traffic. And that is basically so people can operate their conventional dual stack interface and run native IPv6. We will probably be providing Lambda services at some part, and we're already doing it for some projects such as CaveWave and Ultralight. Ultralight is a project that is run in the high energy physics groups, and it interconnects people all over the world. And our particular hub is through the Caltech High Energy Physics. We're actually bringing up connections with NSF grants from Translight. We're actually going to be bringing in connections with our ARNet folks. And we'll be going through Hawaii and picking up all the international telescopes so that we can facilitate a lot of international connections to be able to view the telescopes that are available there in Hawaii. The REN project is actually an NSF grant that is assisting the South American community going from Miami down through South America back up and connecting in Tijuana, San Diego into Pacific Wave at that point. So we'll be bringing in all of our South American and Central American partners as well. So what's for the future? Well, they're actually talking about us doing peering at layer 1, which is going to be interesting. A lot of that's way out in the future, but there's researchers working on it. And the other interesting thing that's going on is how to have people build lambdas across these infrastructures that are controlled by many different entities. And that also brings up the fact that we have funding to do measurement studies as well, because that's also an interesting issue of how do you do measurement when you're not allowed to really see into the devices that you're going through because they belong to a different entity. So those are just a few of the things that are going to be issues for us in the future. So basically, I put down a few of the sites that people want to look a little bit more at, where the glyph site is, the National Lambda Rail. The IEEF is doing a lot of this work, which is the Internet Educational Equal Access Foundation, Translight, and then one of the presentations for the REN project. I don't believe they have their website up. And my one last final comment is I apologize that we're integrating 3 different websites at the moment, so you may not get all of the information you need at the pacificwave.net site, but stay tuned. The rest of them will be integrated in.
One note that I wanted to add, for those of you who downloaded your slides early, the updated slide presentation hit in the middle of the presentation, so if you, the slides that are up here now will actually be available on the website now. So I'll open that up for questions if anybody has questions.
Chris Caputo, Altopia, and also Seattle Internet Exchange. The 6 has an extension point or extension switch policy, and we actually have a few extension switches, one with PAX Seattle I'd like to mention, and Compass Communications, which is now FiberCloud, Colo centers. And I was wondering if, in Cortland, I was wondering if Troy could talk about experiences with interacting with essentially other vendors' hardware in a switch fabric.
Well, let's see. The sign says to speak clearly and speak directly into the microphone, so I'll do so. The policy is that the board of directors of the 6 can approve or reject applications to have folks connect to their own switches. So in this case, if you've got a data center, let's say you're in the Westin or somewhere nearby, and you want to offer the 6 as a service, either free or paid, to your data center customers, you can apply to actually run an extension of the switch fabric. And we get access, so we were able to log in. We're able to do SNMP queries and get logs and what have you. But the actual primary operation is the responsibility of the data center provider. So in that case, it's a little questionable as to what the trust relationship is. We have to make sure they're not going to do anything that would either compromise the integrity of the data that's passing, like ARP spoofing, as well as do something that would compromise the switch fabric itself, become the root bridge, and have all sorts of fun. So there was a learning curve the first 2 or 3 of those, both for me and for other people. I think we've gotten past the hurdle now, and we see a pretty smooth interconnection. For the last 2 have been pretty darn smooth. For the first 2, we ran into folks who maybe weren't as familiar with broadcast domains as they could be. So we started seeing traffic we would rather not have, OSPF, HSRP. So that was a little funky, but it's been a good policy overall. And we connect with PAX Seattle, which has been totally smooth, absolutely seamless.
This is for Celeste, I believe your name was.
Who are you and where are you from?
Oh, Matt Petak from Yahoo. And this may seem like a bit of a naive question, so I apologize in advance, but it starts to appear to me as you outlined your multiple switch interconnects up and down the coast that you're dabbling a little bit in somewhat of a localized transit relationship, in that if you connect to a switch in one location, it seems you can peer with people in another location. Do you find yourself potentially competing with transit providers in any way, or is this seen as completely different space?
We've done a few things to make sure that people aren't using it for transport for commercial purposes, but one of the things, because we are handling a lot of trans-Pacific links where a research entity may only be able to peer either in Seattle or LA, we're facilitating them being able to pick up peers in another location depending on their submarine cable landing so that they can exchange traffic. So this is basically to help facilitate the fact that many of these entities cannot afford to be in more than one location in the United States, or at least on the West Coast. So yes, we are allowing that to happen, but it's basically they'll be peering with people who are not available in their local. So
basically your acceptable use policy on it is what prevents it from being turned into a full-fledged transit sort of exchange.
yes.
Okay, thank you.
Any other questions? Yeah, go ahead, Mike.
Okay, I'm going to ask a question of Troy, and he better not hit me. He's really close next to me. First of all, can I hire you to do my cabling? Because he had this really nice, neat slide of his broom cupboard with all this beautiful cabling in it. So yeah, we'll get cabling tips.
But kudos to our facilities team. Actually, I take no credit for that.
Okay, cool. That's like the neatest exchange point I think I've seen in a long time. That's so sweet. That's beautiful. Anyway, and the serious question was, you were talking about a couple of Extreme boxes. Right now, if I think of the Westin building just over there, it's got your switch fabric in, which is Cisco, and it's got the PAX one, which is Extreme. If you went and took the Extreme stuff, and everybody knows I love redundancy and I love having like multiple selections of vendors and that kind of thing. How do you feel, do you feel anything at all about eroding the vendor redundancy that currently exists within the Westin by moving to say an Extreme switch fabric over somebody else's?
Well, good question. I don't think I feel any emotion about eroding the switch redundancy in terms of vendors. I would feel emotion. In fact, I'd be very sad if I had to erode the features redundancy, in that if there's things we do now to protect ourselves that we couldn't do with a different platform, and if we lost any features along the way, I would stumble. But in terms of what we do, I think it's bare bones enough that that pretty much any switch vendor should be able to pull it off. But no, I don't see an intrinsic problem with having the official Weston building IX be extreme.
Raz, if you don't mind deferring to Woody, is that all right?
Yeah, just a sec. Mike, also that sort of calls for the 6 to predict the actions of switch and data, which is maybe not necessarily a good position for them to bend upon being able to do, right? So it's quite possible that switch and data may, in that facility, as in Palo Alto, switch to a different platform, in which case the redundancy would be just what it is now.
Richard Steenbergen, Inlayer. Troy, you mentioned that you had gotten some free black diamonds, and I just wanted to ask where you got those from, make sure they're not coming from Palo Alto, and make sure that they're not the cursed ones.
Somebody said they were coming out of a data center, Bryant. I don't know if they're free, though.
Oh, boy. Are there any other questions? All right. With that, I'd like to thank all of my panelists. They've done a fabulous job. I think that this is hopefully useful to you. If you find it useful, I'd like to encourage, as would all the Merit people, like to encourage you to fill out your surveys. If you find this useful, please check the box that it's useful, provide lots of wonderful comments, and hopefully they will continue to let us do operator panels as we go forward through the NANOGs. I like doing them. I like working with all these people. Other than that, thank you very much for your time, and Susan. Steve.